Hi students, in the previous class we covered the topic on series, that is already we discussed the comparison test. In comparison test we have three types. First one is comparison test for convergence, second one is comparison test for divergence, and the third test is comparison test limit form. Third one is very useful, but what is the drawback of that comparison test limit form? Otherwise comparison test for convergence, divergence and limit form of comparison test means here to discuss or to find out the nature of the series, we have to identify another series in such a way that that series nature must be known, right? Then we compare the given test and the known series. With these two tests help, and by applying the comparison test for convergence, otherwise divergence or limit form of comparison test, then we identify the nature of the given series, right? So here test for convergence of the series sigma n square plus 3n plus 1 by n cube, right? So summation n square plus 3n plus 1 by n cube. For these type of problems, most widely we use the limit form of comparison test. What is the limit form of comparison test? The statement is, if sigma un and sigma bn be two positive series, right? These two are positive series. And limit n tends to infinity, un by vn is equal to L, which is a finite value and not equal to 0. It is a finite value not equal to 0. Then what is the conclusion? Both the series sigma un and sigma vn have same nature. What is the meaning of nature? Either both the series are convergent or both the series are divergent, right? Both have the same nature. Now we will see. In the previous class already we discussed, when we discussed the comparison test for limit form, right? So how can we choose this sigma vn? Right? Here we are identifying the nature of the given series. So take it as, take un is equal to given series nth term, which is n square plus 3n plus 1 by n cube, right? This is the given series nth term. Now we have to identify vn. Is the given series nth term. So take Vn is equal to, how can we take Vn? The maximum power of n in the numerator. That means what is the maximum degree of n in the numerator? 2 is the maximum degree of n in the numerator. So take that n, that is n square, by, and in the denominator also we have to take the maximum degree of n in the denominator. What is the maximum degree? N cube. By cancelling we get 1 by n. Now we apply the limit form of comparison test. So limit n tends to infinity, un by vn is equal to limit n tends to infinity. What is un? N square plus 3n plus 1 by n cube, 1 by vn, right? So by 1 by n, it becomes limit n tends to infinity, n square plus 3n plus 1 by n cube. 1 by n becomes into n, right? So this n gets cancelled with the denominator, remaining is 2, which is nothing but limit n tends to infinity, taking the maximum degree of n common from the numerator, that is n squared. So remaining is 1 plus 3 by n plus 1 by n square by n square. N square gets cancelled. Now apply limit as n tends to infinity. As n tends to infinity, one by n tends to 0, right? So if you apply limit n tends to infinity, it becomes 1 plus 0 plus 0. What is the value? Which is 1. 1 is a finite number. It is not equal to 0. So what is the conclusion? Implies the series sigma un and sigma vn have the same nature. Right? Already I discussed about this limit form of comparison test. When we apply the limit form of comparison test, we are comparing the given series with the known series. What is that known series? Here we are identifying Vn, right? So what about the nature of this Vn? By p-test. What is p-test? Sigma Vn is equal to sigma 1 by n. P-test is sigma 1 by n to the power p is convergent. When it is convergent, sigma 1 by n power p, summation 1 by n power p is convergent when p greater than 1 and it diverges when p less than 1, right? So by p-test, sigma 1 by n is divergent. Because by using the limit form of comparison test, both un and vn have the same nature, right? Because here sigma vn is divergent when p is equal to 1, right? It is convergent when p greater than 1 and divergent when p less than or equal to 1. Because here the value of p is 1 by n can be written as 1 by n power 1, so which is divergent. Therefore, given series is like that, we will identify the nature of the given series using the limit form of the comparison test. Whenever we are applying the comparison test, the condition is we must know the known series nature. Here, Vn nature must be known, then only we can compare the given series with Vn and identify the nature of the series Un. So here the given series is divergent, right? Next problem. Test for convergence of the series 1 by 2 plus root 2 by 3 plus root 3 by 8 and so on plus root n by n square minus 1 and so on. Because series is nothing but sum of the sequence terms. Here some of the terms are given. It is the nth term, right? Generalized term in terms of n is known as nth term. What is the nth term? Root n by n square minus 1. Right, now we will see the solution of the given sum. So, except the first term, given series can be written as sigma root n by n square minus 1. If you observe here, if you put n is equal to 2 here, root 2 by 2 square minus 1, we get root 2 by 3, right? So, we are writing except the first term. Already we discussed the properties of series. Whenever we are adding the finite number of terms to the series, otherwise deleting the finite number of terms from the series, the nature of the series does not alter, right? So, except the first term, remaining terms can be written as sigma n is equal to 2 to infinity root n by n square minus 1. So, what is un? Un is nothing but nth term of the given series. So, here, given that un is equal to root n by n square minus 1, right? So, here we have to identify Vn in such a way that Vn nature must be known. In general, the nature of Vn is find out using the two tests. One is either geometric series, otherwise using the t-test, right? So, how can we take Vn? Take Vn is equal to the maximum degree of n available in the numerator. Here root n is there in the numerator. That means the maximum degree is 1 by 2 by, in the denominator also, the maximum power of, otherwise maximum degree of n available in the denominator, which is 2. So, the corresponding term is n square, right? So, we will get, after cancelling, 2 minus half, which is 3 by 2. Now, we apply the comparison test limit form. Limit n tends to infinity, un by vn equal to, right? So, limit n tends to infinity. What is un here? Root n by n square minus 1 by vn is 1 by n power 3 by 2, which is equal to limit n tends to infinity. Already in the previous sum also I said clearly, taking common maximum power of n from the numerator and also from the denominator of un, right? So, root n means it is maximum power is root n. From the denominator, after taking common n square, 1 minus 1 by n square. 1 by n power 3 by 2. It goes up, it becomes into n power 3 by 2. So, which is limit n tends to infinity. Root n into n power 3 by 2 is n square by n square into 1 minus 1 by n square. These two gets cancelled. So, now apply limit n tends to infinity, 1 by 1 minus 0, which is equal to 1. It is the limit value, not equal to 0, and also it is a finite number. So, to apply the limit form of comparison test, limit un by vn value must be finite and a non-zero value. So, which is finite and non-zero, implies both series sigma un comma sigma vn have the same nature. Now, first we have to discuss about the nature of Vn. Depends on Vn, then we can easily say the Un nature, right? So, what is the Vn? Sigma Vn is equal to 1 by n power 3 by 2, which is convergent it is in the form of summation 1 by n to the power p. What is the p value? 3 by 2. P is equal to 3 by 2. 3 by 2 means 1.5, which is greater than 1. Using p test, it is convergent, right? By p test. Because sigma Vn, summation Vn is convergent by using p test and limit n tends to infinity, un by Vn value is 1, implies given series sigma un is also convergent. Right? It is also convergent. Already we discussed the properties of series. In that one, by adding a finite term to the given series, the nature of the series does not alter. Here we are writing except the first term because 1 by 2 is a finite number, therefore nature of the series does not alter. So finally given series is convergent, right? Now so next one, test the convergence of root 2 minus 1 by 3 square minus 1 plus root 3 minus 1 by 4 square minus 1 and so on. The difference between the previous sum and this term is, in the previous sum, nth term is given, which is root n by n square minus 1. If nth term is given, we can write directly un value, which is nothing but the nth term of the series. But in this sum, nth term is not given. If nth term is not given, first we have to identify what is the nth term, right? So what is the first term here? First term is root 2 minus 1 by 3 square minus 1. Observe the pattern. Second term is root 3 minus 1 by 4 square minus 1. Now, can you tell me what is the nth term? If it is second term, it is root 3. If it is first term, it is root 2. How can we get that one? By adding 1 to that number. So what is this one? Root n plus 1 minus 1. This minus 1 is fixed value here. So again, in the first term also denominator minus 1 is there. So every term in the denominator minus 1 is there. So if it is first term, it is 3 square. If it is second term, it is 4 square. If it is third term, it is 5 square. So by adding to that number, you will get the denominator term. That is n plus 2 square. Right? So like that we have to identify the nth term, that is un value. Then we have to start the problem. Given series can be expressed as sigma n is equal to 1 to infinity square root of n plus 1 minus 1 by n plus 2 whole square minus 1. Write nth term un. Nth term un is root n plus 1 minus 1 by n plus 2 whole square minus 1, right? So to apply the comparison test, we have to search for Vn. How can we choose that Vn? Take Vn is equal to, now see, what is the maximum power of n available in the numerator? If you observe in the numerator, root n is there. So that we have to write root n by the maximum power of n available in the denominator is n square. Right? Root n by n square means we will get 1 by n to the power 3 by 2. Next we have to find out limit n tends to infinity un by vn. So limit n tends to infinity, what is un? Root n plus 1 minus 1 by n plus 2 whole square minus 1. 1 by Vn becomes 1 by n power 3 by 2. It goes up, it becomes into n to the power 3 by 2. Right? So which is limit n tends to infinity. Taking common root n from the numerator, it becomes 1 plus 1 by n, it's a square root, minus 1 by root n, by taking common maximum power of n from the denominator also, it becomes n square. Inside this square, it becomes 1 plus 2 by n whole square minus 1 by n square into n to the power 3 by 2. In the numerator, root n into n power 3 by 2, it becomes n square. Okay? It cancels with the denominator n square. Now, apply n tends to infinity. As n tends to infinity, 1 by n tends to 0. So, square root of 1 plus 0 minus 0 by 1 plus 0 whole square minus 0. So, what is the limit value? It is 1, which is L value not equal to 0, and also it is a finite number. If L value is a non-zero finite value, by using the limit form of comparison test, both the summation un, that is series un, series vn have same nature. Right? Either both the series are convergent or divergent. Right? So, for that purpose, we have to discuss about the nature of sigma vn. What is sigma vn here? Sigma 1 by n power 3 by 2 is convergent. It is in which form? 1 by n power p. So we have to use p test. Convergent for p is equal to 3 by 2 if value is greater than 1. So by p test, summation vn is convergent implies summation un is also convergent. Therefore, given series is convergent. Now next sum is test for convergence of summation 1 to infinity 1 by cube root of 8n square minus 5n. Right? So here also generalized form is given. So what is the given information? Given that un is equal to 1 by cube root of 8n square minus 5n, right? So take Vn is equal to, whenever we are applying the limit form of comparison test, we have to write the Vn value. Maximum power of n in the numerator. There is no n involved in the numerator. So write constant value 1 by maximum power of n involved in the denominator. N square is there, but which is inside of cube root, right? So like that we have to take the denominator term, which is 1 by n to the power 2 by 3, right? Now apply the limit. Limit n tends to infinity, un by vn is equal to, what is un? 1 by cube root of 8n square minus 5n. 1 by vn becomes 1 by 1 by n power 2 by 3. So it becomes into n to the power 2 by 3. Limit n tends to infinity. So taking common n square from the cube root, it becomes n square, because we are taking from the cube root outside, by 3 we are getting, into cube root of 8 minus 5n by n square into n power 2 by 3. It gets cancelled. 5n by n square, this n cancel with denominator 1. Now apply as n tends to infinity, 1 by cube root of 8 minus, in the second term 5 by n is remaining. 5 by n means as n tends to infinity, 1 by n tends to 0. So 5 by n becomes 0. So what is the value of cube root of 8? It is 2. Right? 1 by 2. 1 by 2 is the limit value, which is not equal to 0, and also it is a finite number. So by limit form of comparison test, both series have the same nature. So what is Vn here? Series Vn is, here we are taking Vn as 1 by n power 2 by 3. It is in the form of 1 by n power p by using p test. What is p value? P value is 2 by 3, which is less than 1, right? So 1 by n power 2 by 3 is divergent for p is equal to 2 by 3. Right? So p test is convergent if p value is greater than 1, divergent if p less than or equal to 1. 2 by 3 value is less than 1, so which is divergent. Because sigma Vn is divergent, sigma Un is also divergent. Sigma Un, otherwise series Un, is divergent. What is Un? Un is sigma 1 by cube root of 8n square minus 5n, right? So implies given series, what is the given series? Summation Un is divergent, right? So like that we have to identify the Vn series, and Vn series must be known. Generally, to check the nature of the series Vn, we have to use only two tests. One is p test, Second one is geometric series, right? So P test is in the form of summation 1 by n power p, which is convergent if p greater than 1, divergent when p less than or equal to 1. Second one is geometric test, which is sigma a into r to the power n. It converges if modulus of r less than 1, otherwise it is divergent. Okay, thank you.